So in this video that you are about to watch, there's some terminology that I feared after watching and proof watching my video that it might not be understood, since I'm trying to make this video for people who have basically zero knowledge of turbocharging. So a few of the terms that I used were PSI, which describes a measurement of pressure called pounds per square inch. And that's literally if you were to have a flat surface and you were to take a 1 pound cube and put it on a 1 inch square space, that's a 1 pound per square inch space, or 1 pounds per square inch pressure. And so I talk about 0 to 100 psi in reference to boost pressure on turbocharging. That's what I'm talking about, is pressure in pounds per square inch being forced into the engine. So basically the air pressure, if it were to hit an obstructed wall and just stop, it would exert said amount of force into the engine, onto that surface, pounds per square inch wise. The second term I used was turbine, describing the turbine wheel inside of the turbocharger, but what I did fail to explain by just saying that they are wheels is that they are actually basically like a fan blade with scoops on each blade, sort of, that kind of offer resistance in a certain way to exhaust gases and resistance a certain way to the air in order to serve a certain function. For the exhaust gases, that's to spool the turbocharger up and use that energy to turn the shaft. On the compressor side, it's to compress that air into the engine to make more horsepower. So I figured I would just add that to the beginning of this video, and hopefully this video is a good guide to how turbocharging works for basic knowledge. Alright, so this is Big Turbo GT again, and today I'm going to be talking about something that I realized I haven't covered on this channel, and that is turbocharging and how a turbocharger works. So this is some basics for some people who might subscribe to my channel who don't understand exactly what I mean when I say I'm all about turbocharged cars, because they may not even know what turbocharging is. So an engine is basically a big air pump and compressor. So you have your piston, and on a modern 4-stroke engine, you have 4 strokes of the piston for each firing cycle. Okay, so your piston's inside of your cylinder, and your first stroke is the first initial downward stroke, which is called your intake stroke, and that's where the fuel and air is injected and sucked into the cylinder, or in the case of a turbocharged system, pressure blown into the cylinder, and gets it ready for the second phase of the stroke, which is compression. And that's where the piston comes up to its highest point and compresses the air and fuel that's inside of that cylinder down to a small space, and then the spark plug fires, initializing the third stage of the four-stroke engine, which is the power or ignition stroke, which is when the spark plug fires and the fuel starts burning at a downward angle, which is called a flame front, and that pushes on the face of the piston, which in turn forces it down. Then the last stroke is the exhaust stroke, when the piston comes back up with the force of the rotating crankshaft from the other firing cylinders at that time, which then opens the exhaust valve and ejects the burned and unburned fuel and air out of the cylinder to where new fresh fuel and air can be drawn in. That's 4 strokes: intake, compression, ignition, exhaust. Okay, with atmospheric pressure, you're talking about 14.696 psi, 14.7, 1 bar is atmospheric pressure. That's the pressure of the air around us on Earth. When you have an engine drawing down, it creates a vacuum as that piston comes in on the intake stroke, which then draws the air and fuel through the intake manifold. Well, unfortunately, you're limited to whatever amount of air that piston can draw in. With a naturally aspirated car, that means no forced induction, no additional other than the stroke of the piston way of getting oxygen into the engine or extra fuel into the engine. So with forced induction, specifically turbocharging, which is what I dabble with, you have basically a secondary pump on your engine, which is an air pump. And what that does is you have what's called a turbine housing. okay, which is this guy right here, and this bolts to your exhaust manifold. So normally if an exhaust manifold would just have your exhaust manifold coming off your head or heads, and then that would have a pipe attached to it that goes straight out of the back of your car. On a turbocharged car, that exhaust flows into this, and inside of this, I don't have a complete turbo to show you, they're all installed on cars at the moment. There would be a turbine inside of here, which is a small metal wheel attached by a shaft to another metal wheel, which is inside of this housing, okay? And with this housing, that exhaust pushes on that turbine, which spools it up, which makes it turn faster until it gets to from between 100 to 200,000 RPM. And it's attached to a compressor wheel inside of this housing. And it turns the same speed as the exhaust turbine does, which in turn creates spinning of that compressor, which then compresses the air that's being drawn in. Instead of it just being drawn in on atmospheric bar, it adds an extra from 1 to 100 psi depending on application, and that is then forced out of the outlet of the compressor into the intake of your engine, which rams a bunch more oxygen and pressurizes a bunch more oxygen into your cylinder on the intake stroke, which then allows a lot more air and fuel to be in that cylinder as it comes up and is compressed, which then is more air and fuel being burned, which creates higher cylinder pressure, which creates more torque, which creates more horsepower. So you have your normal 4 strokes of your engine spinning a turbine wheel attached by a shaft riding on bearings to a compressor wheel, which then forces more air into your engine. So it's using exhaust gases, it's scavenging your exhaust gases and turning that thermal energy from the heat of your exhaust into mechanical energy to turn the shaft on the turbocharger, which then compresses air into your engine, allowing you to add a appropriate added ratio of fuel, which then creates more horsepower. So that's the basics on turbocharging, just in case you didn't know. Thank you. Please like, comment, and subscribe.